Welcome to the world of water jetting. The video you are about to watch is an introduction to the water jet industry and the established safety protocols for operators and personnel. It is presented by the Water Jet Technology Association. Combined with the association's recommended practices booklet, the video establishes a foundation for safety in the workplace. Water jetting tools and systems are an indispensable part of today's manufacturing facilities, refineries, municipal water and sewer lines, aerospace, and many others. Naturally, where such high-pressure water is utilized, there is also the potential for serious injury. The video and booklet are an essential starter kit. However, they do not replace the on-site training necessary to safely operate and maintain high-pressure water jet systems. All operators must be properly trained by qualified personnel and be able to demonstrate that they fully understand the operation and potential hazards. We'll start by describing a basic water jetting system and its critical components. We'll review the dynamics of pressure and flow, general safety concerns, and show you specific examples. We'll look at appropriate protective gear, proper setup, and team coordination. And finally, we'll discuss personal responsibility for you and your coworkers. Water jetting can be divided into two basic categories, manual and automated. We'll look at proper procedures for both aspects. Safety is the foundation of this video, and we'll show you how to safely operate equipment in the field as well as when training operators and new employees. So let's get started. Before we dive in, a quick note about the vocabulary. Water jetting is known by many names, including water blasting, hydroblasting, aquablasting, and more, all describing ultra-high pressure water for industrial and commercial cleaning. In this video, we'll use the term water jetting. Terminology can also vary by application, location, industry, or organization. Plus, over time, terms have been adapted and sometimes changed. For that reason, a standardized set of definitions is provided in the glossary of the Recommended Practices booklet. Jetting applications can look very different. However, there are elements common to all of them. Every system starts with a water supply. This can range from on-site industrial feeds to portable water trucks and holding tanks. Next, the water supply is delivered to a pump, where it is beefed up to drive the jetting tools. There are many different styles of pumps. They can be permanently mounted to a factory floor, like the one shown here, or portable, usually on skids or with wheels. Larger pumps often have additional features like air compressors for powering pneumatic tools and safety features like fire extinguishers and grounding cables. We'll talk more about pumps in a moment. So now we have a water supply and pump power. Before we add a tool to the end of the hose, let's look at the basics of water jet theory, pressure and flow. Pressure refers to the force behind the water in the hose, while flow refers to the volume of water passing through the hose. Pressures in North America are rated in pounds per square inch, or PSI. Internationally, the common metric unit of measure is bar. Tools and systems are often pressure rated both ways. For example, a rotary shotgun rated at 22,000 PSI would translate to 1,500 bar. Flow in North America is rated in gallons per minute, or GPM, while internationally, the metric unit of measure is liters per minute. Tools and systems have flow ratings to go with their pressure ratings. So a tool might be rated for pressures up to 15,000 psi and flows up to 20 gallons per minute. The ratings are critical. Never exceed them. The result can lead to a severe accident. Pressure times flow equals power. For example, a pump operating at 10,000 psi and delivering 10 gallons per minute is producing the same power as a pump delivering 1,000 psi and 100 gallons per minute. The general rule is to use enough pressure to penetrate the material to be removed and then add more flow to get the job done faster. The last critical variable in producing power is the nozzle on the end of the hose. Basically, a nozzle restricts and condenses the jet stream, maximizing the power created by pressure and flow. Think of a garden hose. Turn it on a medium setting and note the water passing through. Now place your thumb over the end of the hose. You just created a basic water jet. Here are some examples of nozzles used in water jetting today. They range in size and complexity from very large, like this one for downhole coil tubing, to this one for sewer jetting, and finally a tiny tube nozzle used to clean heat exchangers. Pressure and flow can seem complex at first. However, with a little experience, you'll understand the dynamics at work. Let's look at some general safety concerns. Naturally, such powerful systems also contain potential risks. First, consider the water stream. Water exits the business end of these tools up to 1,500 miles per hour. An out-of-control tool may cut or penetrate the operator or others in the area. This can happen very suddenly before the pump operator can shut down. Another safety concern with water jetting is a system failure that could cause either a hose, fitting, or tool to be propelled violently by a reaction force. A blow from the tool can be very harmful, even fatal, if struck in the head. We'll cover medical response issues when we look at personal responsibility. Water jet systems often produce volumes in excess of OSHA action levels and the decibel levels mandated in other countries. Never operate a water jet tool or system without appropriate hearing protection. As a contractor, you must respect the environments in which you are working. Frequently, operators must enter into confined spaces to reach the equipment they are to clean. Additional training in confined space entry, lockout, tagout procedures, and other safety considerations are required before entering those environments. Which leads us to PPE, or personal protective equipment. Because water jetting creates an environment where risk of injury is a very real hazard, it is vitally important that everyone properly wears the right personal protective equipment for each specific job. We'll review several options depending on your proximity to the jetting action. Proper body protection, like all PPE, is critical. Operators and personnel removed from jetting typically wear overalls or maintenance uniforms, often with magnetic strips. Personnel enclosed to jetting typically wear rain suits. However, these offer only limited protection from moisture and flying debris. Suits made of nylon with elastomers offer superior durability and are the next level up. Note the additional wrist and hand protection at the end of each sleeve. Suits like this offer the ultimate layer of protection from the water stream. In addition, one-piece hazmat suits may be necessary in cases of chemical exposure. Boots should be made of rubber or other material that will keep your foot dry. They should have at minimum steel toes, and metatarsal protectors are recommended. Hardshell boots like these are preferred. Leather soles are not recommended. They can get very slippery when wet. Hand protection is obviously very important. Gloves come in many lengths. These can be constructed from a variety of materials, neoprene, butyl, and latex to name a few, depending on the requirements for the job. However, cotton gloves are not adequate. Be sure to inspect all gear for cracks, rips, tears, and punctures before using. As we mentioned earlier, hearing protection is essential. The two most common types are earplugs and earmuffs or headphones. Foam rubber plugs inserted into the ear channel offer the best reduction of noise. Because they are inserted into the ear, special attention should be paid to their cleanliness. Earmuffs, commonly called headphones or headsets, cover the entire ear. They don't offer the same noise protection as earplugs, but they can be easier and more convenient to work with. In some situations, operators must wear both earplugs and earmuffs, known in some plants as double hearing protection. Eye protection is provided by glasses, goggles, and shields. Glasses are common when operating control boxes at a distance. Goggles are recommended when working in environments that contain liquids that may cause eye damage. Face shields, sometimes called blast shields, are made of polycarbonate and protect the face and neck from flying debris. All eyewear should be replaced when badly scratched or otherwise difficult to see through. Head protection is offered by a helmet or hard hat. Face shield frames usually attach to the front of the hard hat, and some models have ear protection permanently mounted. Always keep the brim to the front and never drill holes or modify the hard hat in any way. Let's look at how a typical job might come together. Before we get to the job site and actual water jetting, operators and support personnel get together to discuss the work at hand. At the team meeting, those workers involved in providing water jet services discuss specific variables and risk mitigation strategies. Safety considerations, both general and site-specific, are discussed among the team. Your supervisor will share the details of the job, the overall setup, goals and objectives, nature of the material, and risk assessment. In the workplace today, water jet operators can be divided generally into two groups: independent contractors working on site and direct employees of the facility. Plants often produce safety guides like these with everything from emergency contacts to specific details like what facial hair is allowed for working contractors. In addition to specific on-site regulations, risk assessment cards like the one shown here are passed around and discussed. These are often filled out by your supervisor. However, your input may be requested. Additional items discussed in the team meeting should include assigning individual responsibilities, communication procedures and signals, plus any PPE that may be required. Following the team meeting, it's time to prepare the site. Remove any unnecessary items and debris from the area. Secure it with red danger tape and appropriate signage. Both tape and signage should be far enough away from the jetting so that people standing at the tape cannot be hurt from the water jet operations. Sometimes, when the work area is limited, it is acceptable to place barricades around the area to be cleaned to ensure the jetting and noise are contained. Always check with your supervisor before proceeding. With the site cleared and secured, you're ready to connect the components of the system together. Lay the hoses out to ensure you have adequate length and working room. The low-pressure supply line is connected to a source. Note the operator is connecting the supply line to a filter on the pump. The filter does not make the water potable. It just removes debris that can clog and damage lines and nozzles. Pressure-rated hoses and fittings are necessary at this point to connect the pump with the tools and systems performing the work. Hoses and fittings should be marked with a pressure rating. For example, a 15,000 psi MAWP hose is shown here. The MAWP symbol stands for Maximum Allowable Working Pressure. Never use an unmarked hose and never exceed the maximum pressure rating of any component in the system. To ease the identification of high-pressure hoses, the association has developed a color-coding scheme to identify maximum working pressure. These are examples of color-coded hoses. Note the fittings on the ends are also different depending on the pressure rating. Here is an example of a color-coded hose matching the color coding of the operator's tool. The green identification on the hose matches the green on the trigger housing. It's time to connect the high-pressure hose to the pump. Note the operators here are using whip checks, which are safety devices designed to eliminate loose hose ends should a coupling or fitting fail. Here are two examples, one metal and one nylon. Always use whip checks on all high-pressure couplings and never step on a high-pressure hose. After the high-pressure line has been connected to the pump, flush it before attaching to a tool or system. The system is now ready to be pressurized. Using pre-established communication signals, the nozzle operator notifies the pump operator to start the pump and bring the system up to half pressure. If the job is to be performed at 15,000 psi, the pump operator brings the pressure up to 7,500. Then the entire system is checked for leaks or any other indications that there may be problems. If any problems are discovered, the system must be shut down and repairs made. Never make repairs to a pressurized system. When things look good, return to half pressure, and when the nozzle operator and pump operator agree, bring the system up to full pressure. As the job progresses, there are ongoing safety concerns to be addressed. Monitor your equipment at all times. If you notice any difficulties with the general operation, shut the system down and make the necessary repairs. Use the same startup procedures, first half pressure, then full. Sometimes nozzles or tips can become worn or plugged. If this happens, the tips in the nozzles should be changed, or at minimum, the orifices should be cleaned with appropriately sized reaming pins. Before we look at specific tools and applications, let's review the general types you'll find. We've already touched on the two main divisions, manual tools and automated systems. Another key element in water jetting is nozzle rotation and how this is achieved. Most jetting tools rotate, improving coverage and producing better results. This nozzle rotation is typically achieved in two different manners. One is by the jetting action itself, and the other is through powered rotation, usually provided by pneumatic or hydraulic motors. For example, manual shotgun nozzles are free spinners, whereas rigid lancing systems often use hydraulic or pneumatic motors for rotation. That said, let's move on to some specific tools. Shotguns are very powerful tools, both handheld and robotic, with pressures that can top 40,000 psi. Rotary shotgun nozzles usually have 1, 2, or 4 jets, and all the jet action is pointed forward. Obviously, extreme caution is called for. This type of water jetting is used to clean a wide variety of surfaces, such as floors, grates, and between condenser tubes. The main issue with shotgunning is controlling the jet stream. It sounds simple, however, the backthrust created by high pressure can be enormous. Here are some procedures that will help. First, assume a solid stance. Place your feet about shoulder width. Bend your knees slightly and center your weight a bit more toward your forward foot. Cradle the mount to your shoulder and direct the nozzle toward a surface you are cleaning. When shotgunning, there's a tendency to support all of your weight with your back foot as you push against the gun. This is a mistake. If your weight is not fairly well centered between both of your feet, any sudden change in the amount of back thrust will cause you to lose your balance. Always pay special attention to footing when moving about while shotgunning. When activating the gun, close the trigger both slowly and completely. Close it slowly so you don't have a gun that suddenly bucks in your arms. Close it completely so that all the water is forced through the gun and doesn't escape through the dump valve. That's hard on the dump valve, plus you cannot accurately set the pump pressure unless all the water is forced through the gun tip. Shotgunning can stress the muscles in your hand. However, never tie down a trigger or use other means of artificially keeping it closed. Your best chance of avoiding potential injury is to have the water stream abruptly stop by letting go of the trigger. Overall, operator fatigue can be an issue during manual shotgunning. An operator should not withstand a jet reaction force of more than 1/3 of his body weight for an extended period. Lancing and molding are different from shotgunning because the nozzle is used to clean the inside of pipes or tubes. These nozzles still direct a water stream forward. However, they also direct additional streams outward to the side and behind the nozzle as well. This type of cleaning is used for drain lines, sewer lines, supply lines, boiler tubes, heat exchangers, and many other applications where sediments or other products plug or block piping. We'll look at lancing first. If you spend much time in the industry, sooner or later you'll probably run into one of these. It's called a heat exchanger or tube bundle, and it's commonly used for heating up or cooling down chemical compounds in the long tubes. At times, both the inside of the tubes and outside of the bundle need to be thoroughly cleaned. You just saw shotguns cleaning the outside of the bundle. Cleaning the inside of the tubes is typically called lancing. Although there are different kinds of lancing, rigid lancing and flex lancing are the most common. Both can be operated manually or with automated systems. In rigid lancing, the nozzle is placed onto the end of a straight pipe and driven into the tube to be cleaned. Flex lancing refers to the same general process of cleaning tubes, however, with a flexible hose system instead of a rigid lance. Flexible hoses serve two main purposes in water jetting. The first is for a longer stroke, and the second is to clean lines or pipes that aren't straight. Mulling is a subset or type of flex lancing, describing jetting applications with bends or elbows. This can include tools and systems for cleaning sewers, pipes and ducts as well as other applications. The terms can be confusing. Just know, for the purpose of this video, rigid lancing and flex lancing refer to the process of cleaning straight line heat exchangers or tube bundles, while the term molding is used for cleaning pipes and lines with elbows, T's, or L's. Always check with your supervisor to make certain you understand the equipment as well as the specific applications to be performed. Now let's examine potential problems you may encounter when manually lancing or molding. With this type of water jetting, the nozzle is inserted inside the pipe or tube so you can't see the high pressure stream. Because you cannot see the nozzle at all times, precautions should always be taken to control the operation with backout preventers, stingers, and hose markings. First, always use a backout preventer. They mechanically prevent the nozzle from backing out of the pipe or tube, taking human judgment out of play. They come in a variety of styles and are most commonly attached to the end of the pipe or the tube bundle face. Always insert the nozzle into the pipe and secure the backout preventer before adding pressure to the system. Even though backout preventers keep the nozzle in the pipe, marking the end of the hose with visible indicators will also alert the operator that the nozzle is getting close. Brightly colored tape works well. Mark the hose at 6 feet from the end, 4 feet from the end, and again at 2 feet from the end. This series of indicators will alert the operator to the proximity of the nozzle. Another important safety device is a rigid starter rod or stinger that is used between the hose end and the nozzle like the one shown here. A stinger serves two purposes. First, it's a very visible indicator that the retracting nozzle is getting close to the operator. And second, a stinger will ensure that the tool does not double back on itself inside the duct or pipe. Therefore, a stinger must be longer than the diameter of the pipe being cleaned. Always use a stinger or starter rod. Your safety depends on it. Next, always use a pressure dump device. Commonly referred to as foot pedals or dump valves, these devices perform the same function as the triggers you saw on rotary shotguns. The water flow will not be directed into the nozzle unless the foot pedal is depressed. Never operate a lancing system without a dump valve, and the foot pedal should always be controlled by the operator who is actually doing the lancing. Note the operator here has looped the high-pressure hose around one of the legs of his control box. High-pressure water lines can travel or move along the ground during water jetting. Stabilizing the hose with the control box can keep travel down to a minimum. Remember, never step on any hoses. Examining dump mechanisms in greater detail, it is important to follow proper setup and testing procedures when operating dump valves. We'll look at those procedures now. The most common dump valve is a foot-operated pedal. However, if you remember, we saw earlier that shotguns have their own dump valve located at the handle, controlled by the operator's hand. As a third option, dump valves can also be remotely actuated by an air cylinder, and the operator controls it with an air switch or valve. For this example here, we'll use a foot pedal. However, the basic principles and procedures apply to shotguns and pneumatic models as well. Begin by connecting a high-pressure hose from the pump to the intake end of a dump valve or shotgun. Be sure to flush the line before making the connection. Now connect another high-pressure hose to the exit end of the dump valve. After connecting that hose, flush it by closing the dump valve and allowing water to pass through it. When the line is flushed, shut the water off and connect the line to the tool performing the work, making sure the tool is in a secure place. In some work environments, line-of-sight communication between the pump operator and the dump valve operator may not be possible. In those cases, radios are used for communication, either handheld models like those shown here, or units that mount on a belt with a headset. Back to the procedure. The tool or dump operator opens his dump valve and communicates to the pump operator that he is ready for low-pressure water. The pump operator fires up the pump, delivering low-pressure water. The dump operator confirms that the water is coming out of the dump valve, indicating that the valve is open and working properly. Water coming out of the dump valve establishes three things. First, it means the dump valve itself is functioning properly. Second, it means we are connected to the right pump and the right tool. This may sound obvious, but you could be in a large plant with more than one pump and more than one water blast application. Third, it shows there are no obstructions in the line. Next, the dump operator communicates three things. First, that he is closing the valve. Second, that the valve is now completely closed. And finally, that no water is coming out of the valve. To properly set the pressure at the pump, the dump valve must be closed so all the water flow is going through the nozzle orifices at the tool. The pump operator confirms the dump valve is closed and brings the system up to half pressure. When the dump valve operator and pump operator agree that everything is operational, the system is brought up to full pressure. The dump operator continues to monitor the valve, ensuring that there are no leaks. If that occurs, the system should be shut down, repairs made, and the system retested. The pump operator then communicates with the dump operator that the system is up to desired pressure, ready for operation. The dump valve operator may now commence cleaning or release the dump valve to reposition himself prior to cleaning. Today, the industry is trending toward mechanized equipment, often referred to as robotic or automated. This equipment increases safety by removing the operator from close proximity to working water jets, plus it can offer more power for the application. Let's look at some of the automated systems and the safety guidelines that should be followed. We'll start with automated shotgunning. The shotgun here is controlled by the operator in the cab and is being used for concrete demolition. Here's another example of a robotic shotgun at work. Note that in this particular application, the operator is controlling everything from outside the cordoned off area. Lancing systems, both rigid and flexible, also have automated versions. Some are large, others smaller and more portable. Once the system is properly prepped, positions are manned and normal startup procedures are followed. If there are problems or issues with the operation, the entire system must be shut down, pressures bled, and motors blocked prior to any adjustments. In addition, the nozzle should be inside a tube or a machine guard and make certain that no one is within 5 feet of the dump valve. The association recommends establishing an imaginary 5-foot safety zone around all operating equipment. This includes robotic shotgunning, lancing operations, and the power indexers often used to position the lances. Extreme caution should always be used around indexers. They are usually pneumatic or hydraulic powered. The same safety rules and 5-foot safety zone apply for all this equipment. Automated flex lancing machines may not require the use of a backout preventer as long as the operator is stationed at least 5 feet from the blast nozzle at all times. A guide guard, shown here, must extend from the indexer to the tube sheet. The gap between the guard and the tube sheet must be less than 1 inch. It may be necessary to clean the sheet face with a shotgun. Never use a tube nozzle for that purpose. The same 5-foot safety zone applies to these operations, and PPE requirements for operators of all automated equipment will be determined during the team meeting with your supervisor. Finally, a note about personal responsibility. As an operator, you are responsible for not only your own safety, but also for your co-workers and others who may come into the area. If you are unclear about a procedure or have any questions regarding an application, stop immediately and ask the appropriate questions. Don't be bashful or shy. Your co-workers would rather stop and get it straightened out than have a potentially dangerous accident occur. Knowing the proper medical procedures following an accident is imperative. Injuries from a water stream are not always apparent to the naked eye and can feel as minor as a bee sting. Contamination and infection are a serious risk. Follow normal first aid protocol and seek immediate medical attention. Many physicians are unfamiliar with water jet injuries. To address this issue, the association has developed a card to be carried in your wallet, one that provides the doctor with valuable information about water jet injuries. Keep this card with you at all times and keep it easily accessible. It carries technical information for the doctor that could save a life. That's it. We've covered a lot of ground in a relatively short time. If you have questions or would like clarification, scroll the DVD back and review the specific section. You can also source the Recommended Practices booklet. As we stated earlier, watching this video is not sufficient to train you, just get you started. We now turn you over to your training instructor for hands-on application of what you've seen here. The association welcomes you to our industry. We hope your career is safe, productive, and rewarding.